All right. Hey guys, I'm really sorry for not being there. Trying to get over the flu. Today we're going to talk about solving division equations. So one thing that you have to remind yourself of is that when you see an equation written such as this is a division problem, right? So how would we read this equation? We would say x divided by 3 equals 2, right? So if I were to rewrite it, I could write it like this: x divided by 3 equals 2. So right now I just want you to watch, and in a minute you'll do a few practice ones on your own, or with your partner, whoever you're watching this video with. So if you think about it, I'm taking this variable, whatever it is, and I'm dividing it by 3, okay? In order to isolate that x, we're going to use the inverse operation. And what do we know the inverse operation of division is? Well, it's multiplication. That's right. So we need to multiply both sides by 3 to get the value of x. Okay? So what does that look like? Well, let's go to this slide. Okay? In order to model this equation, I only have one x, right? But it's divided by 3. So I can't break my x tiles up, but I can draw on them with dry erase, or I can divide them up like this. So what this says is that if I take x and divide it by 3, this one little piece is going to give me 2 units. Okay? So we cut our x into 3 parts, since 3 is the denominator, obviously. Now, that means that this 1/3 of the x is 2. So that means this piece of x, right, is also going to be 2. And that means this piece of x is also going to be 2. So when I look at this problem, I have 1/3 of x, 2/3 of x, and 3/3 of x, which is a whole x, which means that 1 whole x equals 6. Okay, so that's my model. Now, what did I do mathematically? We talked about the inverse operation. Well, if I'm dividing by 3, in order to solve this, I have to use multiplication. And so what does that look like? That looks like this. Okay, so 3 times x over 3, this becomes 1, right? Because if you think about it, 3 times x over 3, these go away, and it leaves me x, because 3 divided by 3 is 1, right? 3 divided by 3 is 1, so I'm left with 1x. And over here I have 2 times 3. Well, 2 times 3 is 6. So that leaves me with my x equaling 6. Okay? So now we're going to think about the same exact problem, only we're going to look at it from a different perspective. Okay? How can we read this equation? Same one, right? X divided by 3 equals 2. But what's another way? Before we did like this, we rewrote it as a division problem. But how could I write it as a multiplication problem? Okay? Dividing by 3 is the same as multiplying by what? Well, we know that the answer to that is multiplying by the reciprocal. So 1/3 of x equals 2. Okay? So now, just as before, we need to divide the x tile into the number of parts that are represented, right? So over here, we're going to take the same thing, and it said 1/3 of x. Well, if this is x, here's 1/3, right? And we know that 1/3 of x was equal to 2 units. Okay, that means that this third of x is also equal to 2. And this third of x is also equal to 2. Okay, so mathematically, we know that, let's look what this does. So if I multiply, right, the inverse of multiplication is division, right? And to divide, we flip and multiply, right, when we're working with fractions. So 3 over 1 is 3. 1 times 3 is 3. So 3/3 of x, well, what is 3/3 the same as? 3/3 is the same as 1x, but I got to do the same thing over here, right, because it has to be balanced. So 2 times 3 is 6, and 1 times 1 is 1. So we know that x equals 6. Okay? So what was happening here, we were just multiplying x by 1/3. Okay? And if x is 6, 1/3 of 6 is 2, which is where you get this 1/3 is 2. Okay, so now let's look at, what do you notice? Okay, here were the two ways that we just solved that problem. When it was a division problem, we used the inverse operation. So here, we, instead of dividing, because if it's a division problem, we have to multiply. And this canceled out. And cancel just means that it became 1, right? 3, because you look at this, this is like 3 over 1. And that becomes a fraction of 1, which leaves me with my x. And then you do the same thing on the other side of the equal sign. Over here, when you're multiplying by x, you actually divide by the reciprocal. And so that actually becomes a multiplication problem again. And this x just means they go away, right? They become 1. 3 times 1 is 3. 1 times 3 is 3. So if you think about 3 over 3, that's 1, right? And so I'm left with just my x, and x equals 6. So either way, both of these equations work, okay? So using your algebra tiles, let's try this one. 2/3 of x equals 4. So again, the equation means that 2/3 of x is 4. What does the whole x represent? Okay, so the model that we have here shows that 2 of the thirds equals 4. So we have to evenly distribute the tiles between the 2/3 that we have. Then each 1/3 of x equals 2. So basically what that means is that I could take this 1/3 and I could give it to these two. And this 1/3 can give to these two. Okay? So 2/3 of x equals 4, but 1/3 of x equals 2. Okay? But let's look at that mathematically and see if we can't solve that. If I have, I'm going to erase that. Hold on. Okay. So now, sorry about that. If I were to look at this mathematically, 2/3 of x equals 4, and I multiply by the reciprocal, okay? So reciprocal of 2/3 is 3 over 2, right? What's 3 times 2? That's 6. What's 2 times 3? That's 6. Guys, what is 6 over 6? That's 1, so those go away. So I'm left with x. But over here, I have to do the same thing that I multiplied with over here. So I have to do 3 over 2. Well, this becomes 4 over 1. 4 times 3 is 12. 1 times 2 is 2. 12 divided by 2 is 6. So we know that x equals 6. Okay? So now let's compare these two problems. Okay, 1/3 of x is 2, 2/3 of x is 4. Do you notice how we get the same answer? To solve both equations, you multiply the reciprocal to get x by itself. Both equations have the same solution of x equal to 6. Okay? All right. So now you need to get out your paper that says I am in practice dividing, modeling, and solving equations. We're going to do 3 problems together, and then you'll do the practice ones on your own. Okay, so this first problem talks about Alyssa. And Alyssa checked out some library books. 1/4 of the books were mysteries. If she checked out 3 mystery books, what is the total number of books that she checked out? Okay, so first you have to know that this is a division problem, right? But that we can write it as multiplication, because any division problem we can write using the reciprocal. 1/4 of the books were mysteries. If she checked out 3 mystery books, what is the total number of books? So I know that it's 1/4 of x equals 3. So 1/4 of x, that means x is going to be divided into 4 groups. Okay, so you can model this on your paper. 1/4 is equal to 3, which means that this group is equal to 3. Okay, and this group is equal to 3, this 4, and this 4th is equal to 3. Okay, so that means that 1 whole x, if you look at it like this, is equal to all of these units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So based off the picture, x is equal to 12. So let's look at that mathematically. 1/4 of x equals 3. Well, because this is multiplication, we now know that I can go this way. And 4 times 1 is 4. Oops. 4 times 1 is 4. 1 times 4 is 4. Well, guys, 4 over 4 is 1. And 1x equals 3. But we have to also come over here and do the same thing on this side. Well, 3 times 4 is 12. And 12 over 1 is 12. So x equals 12. Okay? Now, there's a way to check, and that's what I'm going to show you next. So let's check it. If 1/4 of x equals 3, we just said that x was 12, right? So what is 1/4 times 12? We'll do the math. 1 times 12 is 12. 4 times 1 is 4. What's 12 divided by 4? Is 3. Does that check out? Yes. When I put it on the graph, because we're talking about an equation, it is equal to 12. So it's going to be a closed dot. And that's it. There's no arrows because it is only 12. X has to be 12. Okay? So let's try this one. Susan made several batches of cookies for her daughter's birthday party. 3/5 of the batches were chocolate chip. If she baked 9 batches of chocolate chip cookies, what is X, the total number of batches that she baked? Okay, so when I look at this one, I have X. Sorry, guys. X is fifths, right? 3/5. So that means that I need to go like this, 3/5. Okay, if 3/5 is 9, that means right here, these are 9. What does that mean 1/5 is? If you look at it, that means 1/5 is 3. So I can fill in these last fifths. See how nice that worked? That's like a little pattern there. That's pretty cool. So now I know that 1/5 is 3, 2/5 is 6, 3/5 is 9, 4/5 is 12, and 5/5 is 15. So let's check the math and see if we're right there. Okay, so 3/5 of x equals 9. Now remember, I can solve this by multiplying by the reciprocal. Well, the reciprocal of 3/5 is 5. Oops, not 5/5, it's 5/3. So 5 times 3 is 15. 5 times 3 is 15. 15 over 15 is, that's right, 1x. And x equals, so we got to come over here and do times 5/3. So 9 times 5 is 45, and 3 times 1 is 3. And we know that there are 15 3's in 45. So we know that by math, it equals 15. So let's check and just make sure that 3/5 of x equals 9. So again, we said that x was equal to 15, so we're going to substitute in 15. So I'm just going to do 3/5 times 15. Well, 15 over 1 is how I can multiply by fractions. We know that 15 times 3 is 45, and we know that 5 times 1 is 5. And so we're left with an improper fraction. 45 divided by 5 is 9. And so we know that we're right. So if I'm going to graph that, x is equal to 15, not 9. This is our check. We know that it's right. 15 is what we got for our answer. So again, it's just a colored in dot. 15, there's no arrows because it's equal to, right? It is just 15. Okay, so let's try this last one. 1/2 of x equals 8. Okay. So Mrs. Jimenez has 8 cups of pink lemonade in a pitcher. If she wants to give each person a 1/2 cup of lemonade, what is x, the total number of people that will receive lemonade? Okay, so think about that. Total number, we know our answer is going to be bigger than 8, right? Because we're taking half of it to get 8. So if I draw my picture, I know that 1/2 of x, if this is x, 1/2 of x is 8. Okay. I feel so great about these pictures. I hope you guys love the models too. Remember, you can be using the algebra tiles. They're there. You can draw on them with dry erase marker. It should wipe right off when you're done. So if I know that 1/2 is 8, I know that the whole is going to be what? That's right, 16. Because if 1/2 is 8, then the other half is also 8, because math works nice like that. So I know that my x is going to be 16. So now let's check it and make sure that we're right. I have 1/2 of x equals 8. Okay. The cool thing about this is that you never have to divide. You can always rewrite a division problem as a multiplication problem by using the reciprocal. So hopefully you're getting that from this lesson. I'm going to rewrite that. So 1/2 of x equals 8. So again, I can multiply by the reciprocal to get x by itself, right? I want x alone. So this becomes 1. And over here, I multiply by 2 over 1. Well, that's going to give me 16, just like we said. And so we know that x equals 16. Okay? So now we're going to check it. So we said 1/2 of x equals 8. Well, if x is 16, right? Let's substitute that in. 1/2 of 16 equals 8. Is that a true story? Yes, because 1/2 of 16 is 8, so that checks out. So again, to graph it, we put it on our number line. Because it's equal, it just is 16. There's no arrows, it just is. Okay? All right. So now you're going to glue this paper into your notebook, and then you have a second page of which you will continue practicing with division. Now remember, any division problem, let's say it's this, x divided by 4 equals 24. I can rewrite that as a multiplication sentence. I can say, using the reciprocal of 4, 1/4 of x equals 24. So I never have to divide. I can always solve it with multiplication. Okay? And then in order to solve that, I would just multiply by the reciprocal equals, right? And so then this would be x equals, oops, that's the reciprocal, 4/1. Um, it won't let me finish writing, but you get the picture. Okay. Okay, so you guys get going, glue your stuff in. If this is 8th period watching, I would expect that you are doing your work and that you are on task, for I have received a great wealth of information over the last couple of days, and hopefully we do not have to go over that in detail when I return on Monday. You guys have a super great weekend and work hard the rest of class.